Hi, welcome to my video on piecewise defined functions, and this video is another problem, is extra problem number 2. So let's do the extra problem. Graph f of x equals, and we have a two-piece function. We got the log of x minus 1 base 2, where x is greater than 1. And we have 1 over x minus 1 plus 2, where x is less than 1. Notice there's no equal sign in here, and we'll explain, no equal to 1 here. We'll explain now in a minute. Here we go. Let's write f of x. F of x is a y, so let's look at the first part. Y equals log 2 of x minus 1, and x is greater than or equal to 1. So when we look at this function as a logarithm, and we have to remember that in logs, you cannot do the log of a negative number here, or you cannot do the log of 0. That means that x minus 1 has to be greater than 0, which means x has to be greater than 1, which is what our domain is here, greater than 1. Now, let's look at the log. So, if we got a base and we have an exponent and we have a number, in log form, we have the log, that's the base, that's the base, that's the number, and this is the exponent. So, this is in the log form. So, this is the base, this is the exponent, and this is the number. So if we write it as base exponent number, that means the base is 2, the exponent is y, and the number is x minus 1. So the exponent is y. Normally we solve for y, but in logs it's reversed. So let's take 2y plus 1 equals x. So x equals 2y plus 1. Notice this is solved for x. So in terms of solving for x, we have an x and a y. But what I'm going to do is that I'm going to put the values of y in first and then come up with the values of x. That makes it much easier. So let's take y to be negative 2. So I'll put a negative 2 in here. 2 to the negative 2 is 1 over 2 squared is 1 quarter. So that's 1 and 1 quarter. Let's go negative 1. 2 to the negative 1 is 1 over 2. And that's a half plus 1 is 1 and a half. 0. 2 to the 0 is 1. 1 plus 1 is 2. Put a 1 in. 2 to the 1 is 2. 2 plus 1 is 3. And put a 2 in. 2 squared is 4. 4 plus 1 is 5. Now what happens is that x equals 1 is a vertical, x is greater than 1. So that means that a log has a vertical asymptote. And the vertical asymptote occurs that you've got to go greater than 1, so you can't have a 1. So this graph, the log has a vertical asymptote at x equals 1. And in log form, the exponentials has, the domain is reals. In an exponential, I can repeat, the domain is reals and the range is greater than some number, the y values. And in logs it's reversed. In logs we have the domain is greater than some value of x and the y values are reals. So if we graph negative x, y is negative 2, x is 1 and 1 quarter. So negative 2, there's x, y is negative 2, x is 1 and 1 quarter. Let's estimate it to be there. y is negative 1, which is here. X is 1.5. So negative 1, there's 2 and 1, so 1.5 that's approximately right there. So when y is 0, x is 2. Y is 0, x is 2. So that's right there. When y is 1, x is 3. When y is 1, x is 3. And when y is 2, x is 5. Y is 2, x is 5. So notice it has the vertical asymptote, so it comes down along by this asymptote. Notice as x goes to infinity, as x gets larger and larger, y is getting larger. So it's going like this. So that's the graph of the log. And again, notice that the vertical asymptote is when you make this equal to 0. So x equals 1 is the vertical asymptote. So there's the graph of the log equation, this log part here. Now, what about the function of y equals 1 over x minus 1 plus 2, where x is less than 1? So let's look at this function. So notice we have a fraction, we have a rational function, polynomials in the denominator. That means we have a vertical asymptote. The vertical asymptote is at x minus 1 equals 0. So the vertical asymptote is at x equals 1. So there's the vertical asymptote at x equals 1. So that's why in this part of the graph, we cannot have x equals 1. And this part of the graph, we cannot have x equals 1 because they're both vertical asymptotes belonging to the log and the rational function. Okay, so let's look at, this is a rational function, so let's look at the horizontal asymptote. So the horizontal asymptote is that if we make x, if x is approaching, notice if x is getting larger and larger and larger on the positive side or on the negative side, that means that 1 over x minus 1, so as x is getting larger and larger and larger, this fraction is approaching 0. That means that y is approaching 0 plus 2, so y is approaching 2. So that means the horizontal asymptote is x equals 2. And so the horizontal asymptote is x equals 2. And again, we're on this side. And the horizontal asymptote could go right on through here, but we're only looking at less than 2. So less than 1 right here. So there's the horizontal asymptote is y equals 2. Just to explain that again. As x gets larger and larger and larger, this denominator, x minus 1, is getting larger and larger and larger. That means this fraction is getting smaller, approaching 0. That means y is approaching 2. So that's the horizontal asymptote. Now, let's look at how this works. So as x goes to negative, we're only allowed to go on this side. So as x goes to negative infinity, y is approaching negative 2. So that means the graph is doing this, or the graph is doing this. So to find out where that graph is going, we'll take a couple of values of x. Let's look at when x is less than 1. So let's look at 0 and negative 1. So let's look at a 0 and a negative 1. So let's put 0 in this equation. So if we put 0, if x equals 0, we have 1 over 0 minus 1 plus 2. That means that's 1 over negative 1 plus 2. So that makes it negative 1 plus 2. So that's 1. So when x is 0, y is 1. And what about when x is negative 1? So we have 1 over, we're putting a negative 1 right here. Negative 1 minus 1 plus 2. 1 over negative 2 plus 2. So that becomes 2 That's a negative a half, so that's 1.5. So let's look at these 2 points. So when x is 0, y is 1. When x is 0, y is 1. That's right there. When x is negative 1, y is 1.5. When x is negative 1, here, y is 1.5. So the graph, as x goes to negative infinity, y is approaching 2. So that means the graph must be doing this. There it is. There's the graph on the left side of 1. And we could also let y equals 0 and solve this out and find out where this x-intercept is. But we don't need it because we have these two. We know it's going to cut this way. And this rational function has a vertical asymptote, so it either tapers down here or up here. But because it intersects here and here, then we know it's doing this. As it goes to negative infinity, the y value is approaching 2. So there's the graph that represents this function. And I wanted to do this one because it reviews logs and is reviewing rational functions. And that brings us to the end of this video. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.